Welcome to the HVAC-OLOGY experience, where we talk about all things HVAC industry, topics that are so hot they are cool.
We are in episode 11. I would like to first welcome my lovely red, white, and blue co-host, Kelly Patterson.
Thank you, Ryan Hudson. I appreciate the welcome.
Aw, well,
You're the best.
You're welcome. So we are in red, white, and blue because this episode is being filmed on the eve of July 4th, where we get to celebrate our nation and the birth of our nation.
Independence Day. But today is also special for another reason. July 3rd is, again, when we're filming. Do you know what the significance of July 3rd is?
Tell me, Kelly.
It is Air Conditioning Appreciation Day.
Oh,
yes.
I'm gonna go ahead and go on a limb. I think a lot of people appreciate air conditioning about the months of June through August, at least in our area.
Yes. And the air conditioning, I think it's Air Conditioning and Refrigeration Institute celebrates July 3rd through August 15th because they're like, we should appreciate air conditioning during these days and make sure your air conditioning is well maintained.
I tell you, keeping your air conditioning maintained turns that unit that lasts 8 to 10 years with a lot of trouble to 15. My air condition actually at my house is 19 years old and runs perfectly fine.
Yeah, ours is 24 years old. I'm waiting for something to happen, but
well, you just said something. So
I know.
So we are in the season of travel. Kelly, do you know where it is when I was a kid, the two places I always wanted to go?
Disney World and Antarctica.
Indiana and Finland. I don't know why I was so fascinated with Indiana, but I wanted to go there very badly. Do you know I wrote a letter to the folks in Finland, whatever their government people are. I figured out how to find that address. Okay. I wrote them a letter, and they sent me back all this stuff about Finland. And I looked at it, and I read it, and I kept it for a really long time until I think my mom threw it out.
What? How old were you?
Like 10.
Finland. That's a weird obsession. And Indiana.
Yeah.
I don't know.
I want to go. I want to go to them. I just do. It's in my heart.
Okay. All right. We'll go.
Is there anywhere you've ever wanted to go?
I want to go everywhere. There's nowhere on this earth that I do not want to. Well, people keep going to Iceland. I'm not sure about Iceland. The name has ice in the title, so therefore less interesting to me.
Well, you do know that was actually strategic, right?
I do, but whatever.
There was a Greenland that was really very cold, and there was an Iceland that was actually pretty nice.
I know. It's just, I don't know. I hear it's really windy there. It's fine.
Oh, man. So today we are going to be talking about boilers. And I don't know about you, but it's getting hot in here as we talk through what a boiler is today with Mr. Joe Britt. Joe Britt, welcome.
Thank you. Thank you for having me. I do think it's a bit ironic that on July 3rd, as we approach the hottest days of the year, let's talk about boilers.
Let's do it.
Well, in defense of HVAC-OLOGY, it's actually a perfect time to talk about boilers because this is the time that you can take them down as a maintenance guy and you can service them.
Absolutely. Very fair point. And now is the time. If something needs to be done, do it now, because when September or October rolls around, things are really clicking, and now we're in a rush. So absolutely fair point.
Yeah. So all the listeners know, Joe Britt is the president of now Hoffman Hydronics, but just a little while ago, Hoffman Hydronics was known as Heat Transfer Sales. And the reason why I'm bringing that up, Joe, is because a few episodes ago, we spoke to Mr. Dan D'Alberto and Mr. Jim Bingham about buying businesses and selling them. And so you were actually a part of that kind of story of being a part of a company that came into the Hoffman and Hoffman family of companies. So kind of just high level before we get into boilers, what was that transition like? Were people freaked out? Was the communication very good? Did the transition happen smoothly? Just kind of connecting it back to those previous episodes we've already had.
Right. Yeah. Well, of course, it was pretty quiet during the initial talks. It was me and Jeff and our two partners were really the only ones who knew what was going on. But I think it's fair to talk about why we looked at selling at the time. We were a very stable business, had been in the industry for decades. We started in late 1971. Was founded by 4 sales engineers, one in Raleigh, one in Greensboro, in Charlotte, and in Greenville, South Carolina. Successful enough up to a point. I was fortunate to be part of the ownership change that took place prior at the turn of 2007, 2008, with my predecessor as president, Jeff Festal, really kind of leading the charge there. But we were successful. But we also had a few things going on that kind of drove our desire to kind of look at other options longer term. One of those is, as our partners were getting later in their career, there's the question of exit strategy. And we see it a lot with rep firms and just businesses in general in this type of industry, especially smaller ones that really don't have a well put together exit strategy. So that was part of it. Being an ESOP, an employee-owned company, was one of the things that we had investigated a few years prior. Wasn't really practical for us to do it at our size at the time, but that was certainly an enticing thought. And then also just looking at the industry around us with other acquisitions taking place, different rep firms joining together, and certainly it was a little bit of a defensive move as well. And then as we started talking to Jim and to Rusty and learning about them and how they do business and their values and our cultures really aligned very well. And there was some things that we did. We were really strong in areas where I think Hoffman could use some help, and then vice versa. So there was just a ton of synergy as we drilled into this thing. And then, of course, the acquisition became formal in February of 2019. We made the announcement. We gathered everybody into different branch offices and let everyone know. But I think we let everyone know that it's going to be a very stable, good relationship, but definitely a mind shift, because as reps, as salespeople, we tend to hold information close to the vest, right? And that's one of the things that I've been fighting my whole career, is that we have people in this industry that want to own this knowledge because they think that's the only way they have value. I'm the opposite. I want to teach. I want to arm everyone that I can with knowledge. And then now that we are part of this bigger team, hey, we can share this information. We can talk about who we're helping out in the field. We can talk about how we can team up. And it's different. And it's taken, we're 5.5 years into this, and we've come a long way, but there's still a long way that we can go. But when we join together and we really utilize the best that we all have to offer within the Hoffman family of companies, man, there's no limit to what we can accomplish.
Yeah, you said something I was actually going to say, that I've seen from afar, and actually I was part of another company that saw some mergers take place, and they don't go very well in some situations. And I thought it was beautiful the way the harmony of what was heat transfer cells and Hoffman. And I think you raised the tide in places, and they raised the tide in other places, and it made it to where all ships were floating very nicely. So kudos to the leadership team of what was HTS, now Hoffman Hydronics, and kudos to Hoffman for making sure that was a healthy marriage.
Absolutely. That those handshakes need to reach across from both sides.
That's right. Yeah.
So
I agree.
It's been really good, and just to talk a little bit more about the name change. Since we've been part of Hoffman, we've been now given the opportunity to represent some of our good vendors in other states outside of the Carolinas. So for decades, we were just North and South Carolina. but through acquisition and through just obtaining some lines into other areas, now we cover most of the Southeast. As we did that, we ran into naming conflicts. So it became necessary for us to do business under a different name in those markets. So we chose Hoffman Hydronics, and then eventually adopted that name in the Carolinas. So Hoffman Hydronics, I think, pinpoints more what we do. It shows solidarity with the rest of the Hoffman organization. And when you look at our business today compared to where we were 5 years ago, we really are a very different company today. So for all those reasons and a few others, that name change was very appropriate. And honestly, I think in the Carolinas, it was mostly a non-event. I think nobody was surprised, and everyone's embraced it. So it's been really good.
Very good. So as we transition the conversation now from just kind of tying that time back to former episodes, kind of what we want to do today is talk through boilers. But before we do that, one of the things that we always like to do with our guests is answer the question of how in the world did you get from graduating high school to where you are at today? And the reason why we do that is because folks are listening to this that might be considering getting into the HVAC field. We want to really tear down the barrier of that. A lot of people come from a lot of different backgrounds to get to where we are today, and so I think this part of the episode always helps break that barrier down. So, with that, Joe, high school to today, 5,000-foot view.
Yeah, absolutely. You know, I didn't grow up just thinking, oh, I want to get into the air conditioning. In fact, I remember asking my dad, I can't remember what age it was. I must have been in high school, or at least the age where I would ask the question about a friend of his. I'm like, well, what does he do? And he said, well, he designs air conditioning systems. And my initial reaction is, oh man, that just sounds awful. Why would anybody? Well, it's just a box. You know, how are you designing that? So I really had no idea. And I think, like a lot of people, and this is especially hitting home today, as I've got a daughter who is 18, getting ready to start in college. Anytime you're trying to find out what your path is going to be, I think it starts a lot with trying different things and figuring out what you don't want to do. Mm-hmm. So I graduated high school and went to NC State, going into chemical engineering. My thought process there was, hey, that's a very challenging program. I'm pretty good at math and chemistry. Let's see where that takes me. And if I got that degree, I could at least have some choices in whatever opportunity I pursued at the end. So I did that. During the course of my college career, I had the opportunity to work. I co-opted at a pharmaceutical plant in RTP. And I learned very quickly that I did not want to work for a very large corporation. I did not want to go to the same building every day. That wasn't me. I also learned through my career that I looked at my classmates, and I was more the type of person that liked to look people in the eye when I talked to them, as opposed to staring at shoes. Mm-hmm. And so, yeah, as I just kept finding out what I didn't want to do or who I wasn't. And then the sales thing really didn't pop up until it came time for recruiting. And a fellow by the name of Ken Stevens, who's a former president of Heat Transfer Sales and owner, he did some on-campus interviewing, and I spoke with him. I did interview with one other sales organization at the time, but that opportunity became really intriguing to me, because one thing that was very valuable to me was whatever I did, I wanted to be sure that I was rewarded proportionately to what I was putting in and producing. And so that production reward meant a lot to me. And then as I learned more about this industry and I saw the complexity of it, I think that challenge intrigued me. I said, hey, this is something I can really sink my teeth into, and I want to be very good at this. And so I started, and honestly, I tell people the first couple of years I did this, I really didn't say a whole lot. I just asked a lot of questions. I observed. I tried to soak in everything I could, and you really cannot learn it all. I still, I've been doing this over 24 years. I still learn something every single day. Now, that something is different. It's not always the technical side of what we do, but certainly it's been a fun ride, a challenge. It'll gut check you. It's not easy, but I started out as a sales guy, and just kind of did different jobs. And I think, I don't know, why am I in the position I'm in? I think I just always tried to treat people the right way. I wanted to be very good at my job, and it was important to me that the people around me were successful. And I think anybody that's looking for a leadership position, you have to define part of your success as the success of those around you. And so until that becomes a priority for you, you're not going to go real far as a leader. Mm-hmm. So when it came time for my predecessor to retire, I was fortunate to have this opportunity to step into this role. And I knew what I was getting into. I was my predecessor's right-hand man for a number of years. I saw what he went through, but I also saw a great opportunity. So the lights are still on, and I think we're doing okay. We have a long ways to go, but we're getting there. I'm excited for the future.
There was a research poll that was done, and it was asked to professional coaches, like on a high tier, very successful level, and they also interviewed some CEOs of business. And they said, what's the one word you would use to define your success? And the answer that actually surprised everyone was the word humble. To be humble was what got them to where they are at. And Joe, I think you embody that very well with your servant's heart as well.
Well, I appreciate that. It's if one were to read the book Good to Great, when they go through the CEOs in that book, they all have similar qualities. And that you cannot carry a big ego. You've got to surround yourself with really good people, and again, take none of the credit but all the blame when needed. And that's how you do it. So I'm honored you would associate me with that kind of quality. Thank you.
Yeah. I think the similar book, Simon Sinek has in a similar vein. Leaders Eat Last, I think is what the name of the book is.
Yep.
But yeah.
Yep.
Well, very good. Well, thank you so much for being vulnerable with us and being willing to kind of share that story of how you got to where you are at today. And so if we can transition a little bit more to the nerd side of the conversation.
Right. I can do that too.
Boilers. So,
right.
As a chiller guy, that kind of cut my teeth in the industry selling solutions revolving around chill water applications, and then air side applications. I get a little nervous when we start talking about hydronics. We start talking about boilers, and so I'm hoping that if there are other folks that are similar to me, that when we get to the end of this conversation, maybe they're not so nervous. So boilers, and just if you could kind of take it through basic, what are the different types of boilers? And what makes a boiler different if it's doing maybe a process versus maybe touching domestic water for people to consume? Kind of, if you could, I know that's broad, but if you could kind of walk me through first, what's the different types of boilers, and then maybe go into, the difference between domestic water usage versus process.
Yeah, easy. 5 minutes. No, that's great. I think if I can go back to, it is a little intimidating. I think especially in the Southeast, because they'll associate boilers with larger systems and hydronic systems. It's just not as common in the Southeast as it is in the more northern parts of our country, where you'll have hydronic systems in many residential homes and houses. So that term doesn't have quite the same connotation there as it would here. But I guess let me, if I can, spend just a couple minutes talking about boiler applications in hydronic systems just in general, because if the listener is out there, we use that term hydronic. What does that really mean? What it means is we are using water to move energy throughout a building or through a process. That's it. Whereas most air conditioning systems, we're doing just that. We are conditioning air. We're applying hot or cold to that air and moving it through ductwork, and we're dumping it into space, which is fine in a lot of buildings. But as you grow that building, the economy of scale is going to dictate what type of system you're going to use. And for anyone that is looking for a system that's going to live the same life of the building, and when you look at the economics of the installation itself, you think about how you move the energy in and out. Now we're looking at water systems and piping systems. Water is a natural heat conductor, energy conductor. Air is an insulator. So certainly, there's an opportunity there, water being completely abundant on the earth. Nature uses water to heat and cool the planet. Why can't we apply that to a building? And I use another analogy as well, as if you look at a hydronic system in a building like you do the human body. The piping system is like your circulatory system. And all your body is doing is moving energy in and out of your body. Well, this is doing the same thing. Instead of a heart, we have a circulator pump of some kind, or many. So that's the analogy I like to use in where hydronics comes from. So all it means is we're utilizing water to move energy in and out of the building. So I hope I explained that okay.
Yeah.
Perfect.
So,
Perfect.
now, when it comes to boilers, boiler, all that means, if you look in the ASHRAE manual, I'm trying to remember the exact definition, but basically it's anything that's putting energy in the water for use for comfort systems or to create steam. And oddly, when you say the word boiler, you're immediately going to think about boiling water and making steam, but that's not the absolute definition of boiler, because when we're using boilers to heat water for comfort systems, we're not boiling the water. So you might know the boiling temperature of water at atmosphere is 212 degrees, right?
Yep.
In a building loop system, traditionally, that boiler would make water at 180. So we're still liquid. We're not making steam. Now with the more efficient boilers, and we'll get into that, we're challenging that temperature and trying to heat buildings with lower temperature water as possible, which is raising our efficiency. And we can get into that a little later. So for commercial buildings, your schools, many of your hospitals and government buildings, what have you, when we're using boilers for hydronic systems, especially in the Southeast, most of the time they're not boiling water at all. We're just adding some BTUs, usually through gas, sometimes electric now, and we can talk about that too. But that's just our means of adding BTUs to the system to be utilized somewhere else in the building. If it's cold outside, obviously we're going to just blow air across those coils to heat the air before it goes into the space. And actually we use boilers a lot in the summertime too. In the summer, we're using chilled water to bring the air temperature down, and what we're trying to do is bring that temperature below the dew point of the air in the system, so that now we're wringing water out of that air, we're dehumidifying, so that it's not clammy in the space. And then once that air is now cold below dew point, we've stripped the moisture out, we need to add some energy back into the air so that it's not uncomfortable blowing on us out of the duct. So that's called reheat. So we use boilers in the South during the summer because we're reheating air for dehumidification. So I hope that made sense too.
Yeah, no, makes complete sense. Yeah, so energy from a physics standpoint can be neither created nor destroyed, right? And so what you're doing is you're taking potential energy and turning it into kinetic energy. You're turning it into something that is of value. And just like you said, taking temperatures and how much you raise them, well, that's the amount of work that any system is doing, right? So if you take 70-degree domestic water, well, there's a whole lot more efficiency to be gained if you don't go 180 degrees, you go 160 degrees. And so there's all kinds of things that we can do to pick up points, if you will, from an energy perspective. So when people throw out the word boiler versus hot water heater, what is the difference between the two of those?
It's the application, and oftentimes it's the materials of construction. So for a boiler system used for comfort, space heating, it's all closed loop, so that water goes out, it's recirculated, it's treated, the air in that system is removed, and it's all closed, it's closed loop. So we have more flexibility in the materials that we can use. It's not quite as sensitive as materials that would be physically touching domestic water. So domestic water has a lot of air, has a lot of other impurities in it. It's treated as we get it from the municipality, but it's going to be far more aggressive to materials than a recirculated loop system would be. And so we have to be mindful of the materials that we're using. There's some other codes and things that get into the safeties, pressure and temperature relief valves, that kind of thing. There's some other minor differences, but really the biggest difference is the application and then the materials that we're using.
So when you say domestic water, you're referring to if I need hot water for my shower.
Absolutely. Another term is potable water. So something that you could cook with. Any water that might be used for consumption in that type of application, that would be domestic water. Absolutely. And I don't lump that in with, there are also gray water systems that utilize reclaimed water, rainwater systems. It's a little bit different. That water needs to go through a treatment process before then being fed into a domestic water system. But yes, that's good clarification there. Thank you.
Yeah, potable, that's one of those things in the industry where everybody butchers that word. It's either potable or you hear it potable.
Right.
Yeah.
Exactly. You mentioned efficiency when it comes to temperatures and all, and one thing that we do find in general in the industry, a lot of people don't understand the efficiency and how you associate that with a certain boiler. And I get it too, because there's so many different kinds of boiler out there. How do you look at the box and say, oh, well, that unit is 90% efficient or 85 or whatever? You can't really tell. So what we spend a lot of time doing is educating people on what really drives the efficiency of these products. And when you talk about temperatures, it's really the inlet water temperature that we're sending to the equipment. So whether it's a boiler or a water heater, when you look at the physics of it and the thermo of it, the colder the water I can put in that heat exchanger, the more efficient my combustion process is going to be. So that's driven, if you think about on a gas boiler, I'm burning some fuel, mixing it with air, and I'm operating at a temperature. Well, if I can lower my water temperature going into that process, then I've done two things. One, I have given a bigger temperature differential between my flame, my heat, and the medium or the water that I'm trying to heat. So the wider that temperature difference, the more drive I'm going to have to exchange heat. That's heat transfer. Heat transfer comes from temperature difference. So I've made that wide. The other thing that making the water cold and the surface area of the heat exchanger cold, what that does is if I can get it below the dew point inside the heat exchanger, because what's a byproduct of combustion? Water vapor.
Yep.
If my surface area can be below the dew point of the water vapor in that heat exchanger, then I can condense. So I can have another process on top of the chemical change. Again, we're getting real technical here. This is high school chemistry, so don't be intimidated. But I've got methane, I've got air or oxygen, and I'm producing CO2 and water vapor. If I can make it cold enough, then I can have another process that will give us a phase change. I can convert that water vapor to water liquid. That's an exothermic process. So I'm gaining more BTUs, about 980 BTUs per pound, I think it is. Now I'm getting even more BTUs into my water out of the gas than I would have ordinarily. So, and we spend a lot of time teaching engineers and really anybody who's interested about this, but the big driver in efficiency is that water temperature coming in. That's a huge part of it. The other part of it too, and this gets more into the maintenance side of things with condensing boilers in particular, is making sure that your air and your fuel ratio is where it's supposed to be. So if I have too much air coming into that process, what I'm doing is I'm moving my dew point and I'm making it harder to condense inside that heat exchanger. So if I'm out of balance on that air and fuel coming in, I could have water coming into my heat exchanger at 100 degrees and still not condensing because I've got way too much air blowing in there. Also, I'm eating up energy on the fan side of things, on that blower, on the burner. So, and then the other side is if I don't have enough air, I can starve that process and I can cause sooting. So now I'm creating soot and I'm fouling up that heat exchanger, requiring it to be cleaned more often. So having that good air fuel ratio is critical to proper operation of these condensing boilers.
Mm.
Now, why wasn't this a big deal before? If I can go into a little bit of history here. So for decades, the industry, and again, I'm talking about most commercial buildings, they were using a style of boiler called a cast iron section, or some kind of big, again, most of it's cast iron made, but it's going to be a high volume vessel. And they operated these things at higher temperatures. They would send out 180 degree water. So if you look at a set of plans that was done 30 plus years ago, the design temperature, even here in the Southeast, was probably 180 degrees, and that water was going to go back to the boiler at 160. Well, if you look at the charts for sizing and selecting coils in the Southeast, we know that you don't need 180 degrees to satisfy a load on design day here. You just don't. So why were we operating at those temperatures? It was to protect those boilers. Those boilers, when you look at the literature and you look at the physics of it, if I sent water back to those things less than 140 degrees, I could crack those heat exchangers. That's called thermal shock. And so that is the one thing we did not want to do. So we had to do everything we can to design that system around that piece of equipment to protect its integrity. But it was like a big tank. It had high volume. That's where you get the 180, 160. And also when you do your BTU formula, BTU equals GPM times 500 times delta T. If I have a 20 degree delta T, then my math to come up with GPM is pretty straightforward. So now I'm just moving a decimal place on the BTUs. So today with condensing boilers, what we try to educate people to do is really look at what your coil needs to satisfy the load on design day. And in the Southeast, I think most people are now pretty comfortable designing around 130 degrees going out to a building on design day. And we can even reset that temperature down whenever the load isn't as big. So now what that allows us to do is not only is that set point temperature down, but our return temperature to the boiler is lower. And I can use a bigger delta T through the boiler. Instead of 20 degrees difference in and out, I can stretch that to a 30 or 40 degree delta T. Now my return water temperature is really getting pushed down to 100, 90, even 80 degrees in some cases, and my thermal efficiency goes way up. So
I've got a couple questions. So A, what is delta T?
Yes.
And B, what is design day?
So delta T is that's simply the difference between what's coming into the boiler and what's going out of the boiler. So when I say 160 coming in, 180 going out, that's 20 degrees. If I'm 130 going out and 100 going in, that's a 30 degree delta T. So it's just that differential. Design day is worst case scenario. So you might find this interesting. In fact, I think, Kelly, you might remember we did a blog years ago on is your boiler plant oversized? And the answer is yes. Well, let me explain why. So when a design engineer is looking at a building load, they have to design that system on the very worst case scenario, which means it's going to be the coldest day of the year, the coldest temperatures of the year. There's not going to be any internal heat gains. So you can't assume that there's lights and computers and refrigerators and other equipment that's adding BTUs to the space, including you can't plan on there being occupied or occupants in the space adding BTU. So it's the absolute worst case scenario that we're designing around here. Now, how many hours of the year are we at design temperature? Usually it's 10, 11. You can look at the ASHRAE handbook and look at bin operating hours, and it's only a handful of hours out of the year. So from that point, 99% of the year, we're oversized. But then when I'm designing a boiler system, I'm not going to be able to find 2, 3, or even 4 boilers that add up exactly to that BTU number that I've calculated. I'm going to have to go just above that. So if I've calculated a building load of like 6.1 million BTUs, I'm going to probably put either 6.5 million or 7 million BTUs of boilers in there or more, depending on who's making the decision. So inherently, we're oversized. That's why if anyone asks my advice on sizing and selecting boiler systems, I never want to advocate for an N+1 unless they're just adamant. Now, we love selling boilers. If somebody wants an extra one, that's fine, but we've got to be sure that it's controlled in the right way. What I would prefer to do is have multiple smaller boilers to be able to handle the total load, because most of the operating year, it's kind of like that 80-20 rule. 80% of the year, we're going to operate at 20% of that design load or less. So it's far more important for us to be very effective operating at that minimum load than it is the max. And if a boiler happens to go down, well, in most cases, we're probably still going to have plenty of BTUs left in the system still operating. So, and that strategy hasn't done me wrong yet.
Yeah, similar to the chill water application, IPLV, intermittent part load value, to where 1% of the time it's operating at 100%, and the rest of the time it's operating in that window of like 25 to 75. So yeah, very much applicable. Thank you, Joe. So, I think you've kind of hit on it so far, but just to kind of bring it home, one of the things that I've noticed over the years is I would walk through a lot of industrial sites. That's kind of my forte, and where people like to utilize my talents, if you will. And I noticed that every single place I would go, you would see this pipe running on the roof, and it was all rusted out, and you'd say, what is that? And he said, oh, that's the steam, and we've abandoned it. And as you continue to go to a lot of these manufacturing sites, industrial sites, you see that they're abandoning the steam pipe application. Kind of why do you see that? And I think that kind of gets to our next conversation. But why do you think all the industries are moving that direction? Because obviously it's highly inefficient and highly ineffective and cost prohibitive to do steam pipe these days, because there's a lot of money involved in running that pipe. Kind of what was the thought, and then what got us to where we're no longer doing that anymore?
And this is my opinion, and just based on observation, as I've gone on these job sites and talked to people as well. But it's not limited just to industry, but a lot of other types of buildings, hospitals, military bases, university central plants. Steam was very common. And you had people who were very comfortable operating these systems. And I think there's two reasons why we're seeing less and less steam. One is I do think people are trying more now to find ways of either heating and cooling buildings with low temperature hot water and high temperature chill water. That's more efficient. So I do think people are looking at that more, and they're more comfortable with that. But two, I think in our industry in general, the industry has not done a good job of recruiting and training talent over the years. And so when you look at steam or even pipe fitters, and Ryan, you would know this directly, just finding a good pipe fitter is very difficult. Mm-hmm. Yeah, as we see more kids going into school and coming out of school, you have more people that they want to be in front of a computer screen and whatever they do, and that's fine, but we still need people to do this other work as well and to learn a trade. And so I think the lack of education, the lack of promotion on our industry's part, and the lack of talent here is another reason why people just aren't as comfortable with steam as they used to be. Now, that said, we do still see quite a bit of steam. There are still processes out there that are going to require steam, and we do quite a bit of that. But it is not as prevalent as maybe it once was. So that's a fair statement.
Hmm. So whenever you're putting in a boiler, you have to have a double wall vent whenever you're exhausting that air. Why is it that you have to have a double wall in certain situations?
So the double wall is dictated by the category of flue vent that's required for that appliance. So when you look at those categories, there's category 1, 2, 3, and 4. And basically, your 4 is going to be double wall at all times because that flue vent especially coming out of a condensing boiler, it's going to be pressurized. Mm-hmm. So it's not natural draft. It's going to have some kind of forced draft. And two, it's going to be condensing or low temperature. So that double wall is it's an added layer of safety. If it were to fail, there's at least something else there. It also gives that gap between the two walls is an insulating factor that also protects whatever else might be adjacent to that flue vent. But that's all dictated by the fuel gas code. Mm-hmm. We do see some other materials. If I can, since you brought up venting, we see some other materials being utilized with that more. We see more polypropylene being used on condensing boilers, and that's perfectly fine. That is a UL listed venting material. It can handle temperatures up to, I believe it's 230 degrees. I caution people because I know there are manufacturers out there, boiler manufacturers and water heater manufacturers for gas appliances that say that it's acceptable to do your flue vent with PVC or CPVC pipe. And I'll caution people against that. There's a couple reasons. One is the temperature ratings for PVC is going to be around 140, 145 or so. CPVC is going to be around 180, 185. So when you're operating a boiler or a water heater, you're going to be operating close to the limits of that material. And then the other reason is it's not a UL listed venting material. So if an installer or an owner purchases that material to vent their appliance, they're really taking on all the risk. So, and I caution my manufacturers as well, like, do not put that in there. Why would you recommend a material that, even though fuel gas code says it's okay, it's just not a good idea. And you're not going to save any money versus polypropylene. If you don't want to buy the more expensive stainless, then use polypro.
Mm-hmm. Very good. Thank you.
Little safety tip.
Yeah, thank you for taking that rabbit trail with me. So I can remember walking through the AHRI Expo in, I think, Chicago this past time. And one of the things when I was walking through all the different boiler manufacturers is seeing this trend of going to electrification. Mm-hmm. And just the excitement that seems to be going around the industry. So kind of, if you would, at a high level, Joe, take us through how in the world did we go from this boiler being this thing down in the basement that was the most inefficient thing in the mechanical room to where now we're starting to, it seems like the industry is really thinking outside the box and transitioning over to electrification. And I guess, and if you have that knowledge, what efficiency gains have we had in technological advances to get us to where we can move to this trend of electrification?
Right. That's a great question and a topic of conversation that's been coming up quite a bit. First off, we do offer boilers that utilize both gas or electric as the fuel. We want to be sure people have that option, but without getting too political, just what I'm seeing, there's a big initiative through ASHRAE, through other societies to try to minimize pollution and greenhouse gases. Mm-hmm. And of course, a greenhouse gas is CO2, which I mentioned earlier is a byproduct of gas combustion. So we're trying to clean up the environment, which absolutely we should do as good stewards of our environment and this planet. We want it to be here for a long time for our kids, grandkids, whoever we leave behind. Certainly we're all about that. I don't think a lot of the pollution problems are necessarily, it's not from your more developed countries. Mm-hmm. And so what I see is we keep refining and doing more and more and more and getting more efficient in at least the U.S. So there's big opportunity to educate and help some of the other developing nations around the world so that they can minimize their impact on the environment. But I would say that in the States, traditionally we've done a good job, especially as we've moved a lot of things to condensing boilers. So there are things that we can do maintaining the units that we have more effectively. That goes back to having skilled maintenance and service technicians better education from manufacturers and manufacturers reps to be sure that people understand what to do to keep these boilers running and running efficiently. So that's something that we have to continue to do. But I also think as an industry, we need to be sure that we're educating people on the reality behind using gas versus electric. I'm part of the ABMA Rep Council. ABMA stands for American Boiler Manufacturers Association. And we had a meeting in Denver at their expo back in early May. And we acknowledged that the industry has not done a great job on educating people during this, I'll call it, what they call it, the war on combustion. So there's a perception out there that electric is far more efficient than gas. If you're looking at it from a building standpoint, that can be true. The electricity that we have coming in to the boiler, all those BTUs are converting and going into the water. Whereas with a boiler, if we do a good job, we're getting over 90% of those BTUs coming in through the gas. The rest of it's lost out the flue vent. Okay, that's fair. However, what we're ignoring is how the energy gets to that building.
Mm-hmm.
So let me back up a little bit and let's talk about electricity generation. So through most of the United States, we have nuclear plants that carry the base load for most electric grids. Those nuclear plants will operate up to a point, kind of like a boiler plant. They've got a max capacity. On a day like, I think, Friday, we're supposed to be over 100 degrees. The nuclear plants are going to be tapped out. What does the power plant do to continue to service electricity to the grid after that? They kick on the natural gas generators, which I know I got a letter in the mail. Funny, I just got back from Denver in May, and there was a letter in the mail from Duke Energy that they plan on building a new gas turbine generator plant. They're going to be adding 2 425 megawatt gas turbine generators to the Catawba River plant. Mm-hmm. Okay, interesting. I thought we were trying to get away from natural gas. Here we are using more of it. Okay, well, fine, whatever. But anyway, nuclear is tapped out. Then we use natural gas, which is more costly. That's more expensive to make electricity with natural gas. The efficiency of those turbines, by the way, is 40% at best. All right. And then when the gas generators tap out, now we're using coal-powered generators, which is the least efficient and the most expensive. So when you have a commercial building, you see on the electric bill that demand load, that has to do with how much energy you are using during peak demand. Because now we've bought it and we've generated that electricity with the most inefficient and expensive methods. So that's how that works. Now, the electricity's made, okay, that's great. Well, if it's nuclear, that's pretty clean, should get to us fine, right? Well, electricity, as it travels through the grid to point of use, there's going to be line losses. It's going to go through substations and transformers. And so the energy that we've generated at the plant is not going to be the same as when it gets to our house or our commercial building. So we've had a lot of losses from that, even if it's generated by the cleanest methods, be it nuclear or hydraulic, think about the Hoover Dam and those places. The BTUs through natural gas, when it's pumped out, that BTU content is going to be the same from the point of generation to the point of use. So when you look at it overall as a whole, what's really more efficient in most cases is going to be natural gas. Mm-hmm. Now, what we have though is we'll have building owners that'll make decisions though. And there was a good example that was brought up in a rep meeting a couple of AHRI expos ago. There was a rep that was helping a distillery in East Kentucky. They distill for bullet bourbon. They were designing a steam system using gas boilers. They worked on this for 1.5 years. When final approval went in front of the board of directors for this distillery, the board being located in Ireland, they made not an economic decision, but I guess a marketing decision that they wanted their building to be carbon neutral. or at least close to it as possible. So they decided to use electric boilers to make steam as opposed to gas. Okay, well, what does that mean? It means that they're willing to spend 30% more on their utility bills all throughout the year so that they can say they're a carbon neutral facility, which is great. From a larger picture perspective, though, how do you think they make electricity in East Kentucky? It's coal. It's coal. Yeah. So
interesting.
So it's all about perception, how this is marketed. You know, people hold different values, and we just want to be able to support them no matter what's most important to what they're trying to accomplish. So we try to be as agnostic to this as we can, but we've got to educate people on the truth behind it.
Yeah. So huge rabbit hole that I'm just going to put my toe into it. I'm not going to go all the way into it.
Yeah.
But in my sales days, I traveled a lot to the middle of nowhere. And what I noticed is that there would be these mill villages. And back in the day, like turn of the century, like early 1900s, they had power out there. And the way they had power is that the manufacturer would have hydroelectric dams locally, and then they would have localized energy solutions. Now you say to yourself, well, Ryan, they didn't have to have that much power back then. You know, these little houses, these mill village homes had like a couple light bulbs and no HVAC, right? Well, the thing is that in my mind, the hydroelectric concept has gotten far more efficient than it was turn of the century, and the parts and pieces have gotten far more efficient. I mean, just the light bulb, the evolution of the light bulb to where we're at today. I've thought to myself, why can't we get back to some version of localized energy for localized places, and that way you don't have power going all over everywhere, and the little towns have the ability to be their own solution. But I don't know. I've thought about that. You know, just of course, you know, you're driving 5 hours a day to go see a customer. you tend to kind of go down rabbit holes, but. Anyway.
Well, you know, when you look in areas like California, many of their homes have some sort of solar panels installed on top. In our old building, we had a solar panel system, PV on the roof, and you know, every now and again we could feed energy back into the grid because we were producing more than we can consume. So I do think there's a lot of merit to try to utilize the resources that you have on your property and use some renewables if you can. And we'll see more of that, you know, as photovoltaic and other technologies keep getting better and more economically feasible for most people. I think they'll gravitate toward it. But for now, what we see is everyone, especially as you move larger gas appliances over to relying on the grid just is not designed to sustain the loads that we're putting on it. In the Southeast, we're not seeing this as a problem nearly as much as we are areas north and again in California, where they're doing rolling blackouts very consistently. I don't think it was that long ago we heard that, hey, you know, stop charging your electric cars right now. You know, it's energy is just scarce, and there's some politics as to why they have the scarcity they do in that particular state. But we're seeing it more and more, and as we load up the grid, it's going to require more infrastructure to be able to handle it.
Yeah, you say all this as I just yesterday rode for the first time in a Cybertruck, which was amazing.
I want to try it.
It was someone at my gym has one of those. It's fascinating.
Yeah, it was the Beast Mode edition, and so we drove that vehicle very fast in a place we probably shouldn't have, but it was fun.
Yeah.
Well, very good. So I feel like we've I think there's a whole lot more that we could unpack with all of this, but I feel like you've kind of helped us understand what are the different types of boilers. I think you've helped us understand, you know, what are the inefficiencies of boiler plants, and then what have we been doing as far as the evolution of boiler plants, and then also kind of diving into this concept of electrification. I think we've nailed out some pros, and I think we've also nailed out some cons that I think the future will have to unpack a little bit. But any kind of last thoughts before we kind of close out, Joe?
Yeah, I would just recommend to everybody, educate yourself as much as you can on these systems and how they're applied and how they need to be maintained. Most people, now we like to think that our vendors make the best products that are available. And I think in some cases I could argue that, but at the end of the day, all anybody really wants is to have heat when they need it. They don't want to have to spend a lot of money on it once it gets there, and they just want it to run. And so there's a few things you have to do well. Is you have to design the system well for the piece of equipment you're using. And it's not just in the mechanical room. This also gets into flow rates. If it's different pumping systems, variable primary, secondary. I know we don't have time to get into all that today, but we've got to have the right minimum flows. We have to be controlling things the right way. And then please maintain the equipment. I know people like buying extended warranties. We get asked more and more about that kind of thing all the time. But when somebody claims warranty, what's the first question that's going to be asked? Can I see your maintenance records?
Yep.
Mhm.
It's extremely important. So if they're well maintained, if they're installed and properly in a system that is designed properly, they're going to last a long time in most cases. So that's my biggest advice. And that's why we're here. We're here to help people with all of those things.
Yep, and that is a pressurized vessel, and it needs to be inspected on an annual basis, and because they can explode if they're not maintained properly. So it's
on the steam side, yes. I think on the condensing boilers, the worst that I've seen happen is if you have a call for ignition and it doesn't light, but somehow the combustion chamber fills with gas and then it lights, you'll get a loud pop. I've seen instances over the years where the flue vent cap has ended up in a parking lot a few blocks away. So it's in most cases, I'm not going to say it's impossible to explode one of those things, but it's really hard to do it with those, especially with the safeties in place. But when it comes to steam, especially a big fire tube type of boiler, you better know what you're doing when you step in that mechanical room. And I know there's annual inspections for all this, but this equipment's too important. It's too expensive. It's too costly for something to go wrong. That you need to be looking at it as often as you can, every day if you can.
very good. Well, I have learned some new things today. Kelly, have you?
I always learn something. Joe is my first teacher in this industry, actually. So, but I learned today about the inlet water temperature. That was something that I had missed earlier in my education, and knowing that inlet water temperature needs to be cooler, which I would have not guessed that.
We can make any boiler condense, whether it's called a condensing boiler or not. All we have to do is put cold water in it. It's just, if we do that on a non-condensing boiler, it's just not going to last very long.
So, Kelly, would you say that Joe is your boiler Jedi Master?
100% he's the boiler Jedi Master. Actually, all things hydronic. I bow to all of his knowledge.
That's a lot of pressure, but I appreciate that. I
Pressure,
do take
steam.
pride in at least having a good fundamental understanding of these type of systems. And I tell people, we're hiring a lot of people, and we have for the last few years. The main thing I tell them is focus on the fundamentals. These systems can grow and be complex, and the equipment's different. It's got different names, styles, but the fundamentals behind what we do, the physics behind it, it's universal. It's not going to change. So, and I think about Michael Jordan. If you saw the Last Dance documentary, one of the things that his peers would always say about Jordan, he was this great talent and all, but his fundamentals were flawless. And that's how we should be in what we do.
I tell you, who has got the kind of luck that Michael Jordan does to where he puts out a documentary like that right as COVID happens and nobody has anything else to do but to watch that documentary?
Oh, you think that was luck? That dude makes his own luck.
Yeah. So thanks again, Joe, for taking some time on HVAC-OLOGY to talk through boilers. And we were talking earlier, Kelly and I, about hoping to get you back on about a couple of different other topics. But with that, if you have been enjoying our episodes, make sure you like and subscribe, and please leave comments that would make us smile. And
please.
Please, pretty please.
Do accept flowers.
Yes. And also, if you have an idea about a show, please send us a note through our social media outlets, and we will definitely get it on the docket. But with that, thank you all, and have a great day. Bye.
Bye.
Thanks for having me.
Took a rocket past Saturn. Things don't seem to matter much to me anymore. Got lost inside a daydream. Get sick of all schemes they play on their machines. Lost so many words as I got older. You would have thought I would have stored them, and I'm on your love folder. Accidentally wrote these words down. Thought all the best of me faded in an endless sea. But you always bring me back at your blue eyes. 20 years of staring at that freckle on your left shoulder. Who would have thought all I needed was to think of you to bring back the words inside? But you always bring me back at your blue eyes. 20 years of staring at that freckle on your left shoulder. Who would have thought all I needed was to think of you to bring back the words inside of me? I drove an hour to see you. Things just seem to matter more to me anyway. Got lost in reality, no answers to cancer, we never got to talk. Lost so many friends as I got older. Wish I had the strength to hold you a little bit longer. Always meant to write these words down. Thought all the best of you faded in an endless sea. But you always bring me back at your blue eyes. 20 years of staring at that freckle on your left shoulder. Who would have thought all I needed was to think of you to bring back the words inside of me? Get your